Hello everyone. Uh, Today we are going to discuss something really interesting. Mathematical modeling is when you translate a situation into a math class and you find an equation or you express a situation mathematically, right? That is called mathematical modeling. Now, something that is already in mathematics, can we further model it? Yes. So today we'll explore how to model a sequence or how to find equation of a sequence. So before we move on to this, let's review what a sequence is. So sequence is basically a list of number. It may or may not have a pattern. For example, 5, 8, 11. So this clearly has a pattern. You keep adding 3 to get subsequent terms of this sequence, right? This is an example of another sequence where you have squares of numbers, another sequence. So a sequence may or may not have a pattern, but usually a sequence has a pattern. Now this pattern can be represented with the help of an expression, or we can say this is the model of a sequence or equation of a sequence, and that is called a general term. So using that pattern or general term, we can find each and every term of the sequence without writing the sequence to certain terms. There are different types of sequences. A sequence can be defined on the basis of the pattern. For example, look at this: 2, 4, 8, 12. This is the sequence. Now, if you find the difference of these terms, first term and second term, the difference is 2, second term and third term, difference is 4. So these differences are 2, 4, 4, 6, 5, 6. These are differences of two consecutive terms, right? So this difference, when you find the difference between two consecutive terms first time, we call it a first difference, the first difference. If you further move on in the same fashion, if you find the difference of these differences, so if you find these differences, you will get 2, 0, 2, -1, and so on and so forth. And this is called second difference, right? If the first difference of a sequence is a constant, we call it a linear sequence. If the second difference of a sequence is constant, we call it a quadratic sequence. If the third difference of a sequence is a constant, we call it a cubic sequence, and so on, so forth. So linear, quadratic, cubic, etc. So if you're given a sequence, your general term or the formula or the model of that sequence will be, if it is a linear sequence, you will get a linear expression. If it is a quadratic sequence, you will get a quadratic expression, right? And if it is a cubic sequence, you will get a cubic expression for that sequence. So let's move on and explore how to identify a sequence and then how to find the general term. There are multiple ways to do this. So I'll be using a method. There are more methods. Maybe we will discuss those methods in some other discussion. Look at this example. Find the general term of the following sequence, hence find its 12th term. So you have been given a sequence 5, 9, 13, 17, 21, and so on and so forth. You've been given first 5 terms. Now, you don't need to write up to 12th term. So we'll just find the general sequence. That will be a formula to find any specific term. So what is the first thing? Let's check the difference. What is the difference between these terms? 5, 9. So 9 minus 5 is 4, 13 minus 9 is 4, 17 minus 13 is 4, 21 minus 17 is 4. So your first difference is constant, which is 4. Since the first difference is constant, it has to be a linear sequence. If it is a linear sequence, we can assume that its nth term is an plus b, which is a linear expression, right? Now, what is a here? Your a and b are going to be some constants depending upon your sequence. Out here, A is always the difference, the common difference. 9 minus 5 is 4, 13 minus 9 is 4. So this difference is common to each pair of consecutive terms, right? We call it common difference. So A is nothing but the common difference, which is 4 in this case. And B is always the first term minus the common difference. So in this case, it will become 5 minus 4, that is 1. So you have got value of A, you have got value of B, just plug in here. So the nth term will become 4A plus 1. So this is a formula to find any term of this sequence. When you put n is equal to 1, you get first term. When n is equal to 2, you get second term. You can check n is equal to 2. So 4 times 2 plus 1, that is 8 plus 1 is 9. Right? Fifth term is 21. Just check. N is equal to 5. 4 times 5 is 20 plus 1 is 21. Right? So the question is find its 12th term. How do we find 12th term? Just plug in n is equal to 12. 4 times 12 is 48 plus 1 is 49. So your 12th term will be 49. So that's how we can find the linear pattern of a sequence, which is a linear sequence. Now, moving further, let's identify for another sequence which is not linear. So find the general term of the following sequence and find its 12th term. Now your sequence is 14, 27, 44, 65, 90 and so on and so forth. So to start with, number one, find the first difference. So what is the first difference here? This is your sequence 14, 27, 44, 65, 90, 27 minus 14. So your first difference will be 13, 17, 21, 25 and so on. These numbers are all different. It means it is not a linear sequence. So if it is not a linear sequence, what is next? We find the next difference. So let's find the second difference. 13 minus 17 minus 13 is 4. 21 minus 17 is 4. So your second difference is all 4, 4, 4, 4. Now, since the second difference is constant, it has to be a quadratic sequence. If it is a quadratic sequence, we can write its general term or the nth term. It will look like an squared plus bn plus c, a general quadratic expression. Now, out here, a, b, c are constants. Now, how do we find a, b and c? Again, there is a shortcut to do this. A is always the second difference, which is 4 divided by 2. So in this case, A will be 4 upon 2, that is 2. So value of A is 2. B, what is B? B is the first difference. The first number in the first difference minus 3 times A. So 13 minus 3 times 2 is 6. So 13 minus 6 is 7. So value of B is 7. And for C, the formula is it's always first term minus value of A that you've just found minus value of B. So what is the first term here? 14 minus 2 minus 7. So 14 minus 9 will be 5. So once you got this, your nth term will be 2 an squared plus bn plus c will become 2n squared plus 7n plus 5. Right? So this is how we can find a mathematical model for a quadratic sequence or general term of a quadratic sequence. Now find its 12th term. So just plug in n is equal to 12 here. So 2 times 12 is squared is 2 times 144 plus 7 times 12 plus 5. I leave it to you. You will find it. And this is how we can model a sequence. First thing is identify type of sequence. Then write the general sequence, find the value of coefficients, and you're done. I hope you found this video useful. If you found it useful, please consider subscribing it, like it, share it, and don't forget to press the bell icon. You know why? Because you should be the first person to be notified when a new video is posted. That's all for now. Till we meet again, take good care.